So I'm very pleased to have the opportunity to talk about what we're doing, the research we're doing. It's done against the background of poor health in London, in the areas that we have as our catchment area for cardiac patients. We have a catchment area of approaching 4 million people. We have one of the highest levels of heart disease in Europe. And we started thinking about wine from the perspective of seeing whether we could have an evidence-based approach to improving people's health through diet. Perhaps not necessarily using wine, but by understanding how it was that wine was beneficial. So we hear a lot about the French paradox. This is a term that was coined in the early 80s, and obviously it's Serge Renaud's suggestions that wine consumption accounted for the French paradox that stimulated a lot of wine, an increasing level of wine consumption over the 1990s, and as we saw yesterday, the figures continue to increase. But really the French paradox is a reflection on the low level of heart disease despite what we would consider an unhealthy diet. Now, the sort of study that really got me interested in wine is the Leone diet heart study, which clearly Professor Renaud was involved in establishing these investigations. And what was fascinating about this study, if you're not familiar, the data shown on this slide is from the 400 men that had had a myocardial infarction, and they were followed up for a further 4 years, and they recorded a number of further events that occurred in this group, either myocardial infarctions or strokes. And they recognized that those who were moderate drinkers of wine on a daily basis had a 50 to 60% reduction in risk of further events. Now, from a cardiovascular health point of view, that's fascinating, because if you take the best medicines we have available, aspirin and clopidogrel, we can only cut that risk in a similar group by about 30%. So wine seemed to be twice as effective as the best pharmaceutical combination. So that's why we need to understand how it works. Now, these are the sort of suggestions that have been put forward over the years about how wine is beneficial for health. Increased HDL cholesterol, reduced LDL cholesterol oxidation due to antioxidant activities of red wine, antithrombotic actions, and increasingly studies showing direct effects on blood vessel function. And clearly some of these are important, like increased HDL cholesterol, but they can't explain why red wine might be more beneficial than white wine. So the sort of approach we have in our research is we consider both the process of heart disease in terms of what are the triggers that make it happen, and also what's happening at the end stages. Are we able to reduce the risk of thrombotic events in people that have already got disease? And much of our interest over recent years has actually focused on the endothelial cells that line the blood vessels, because there is no pharmaceutical that can treat endothelial dysfunction, and endothelial dysfunction, as you know, is the precursor to heart disease in pretty much every circumstances. Whatever the risk factor is, it's the endothelial dysfunction that causes the progression. There is interesting stuff, particularly antiplatelet studies that have been done, antithrombotic effects, but today I'm just going to focus on the endothelial effects that we've been researching. Now, to do this, we've cultured endothelial cells from the aorta of various species, including human, bovine, porcine endothelial cells, and using those cells, we can use them as a bioassay to look at all sorts of biochemical mechanisms that could underlie the response in the vasculature. And we're backing this up by doing clinical investigations, intervention studies, to support the data we find from these lab-based investigations. The advantage of the lab-based investigations is things like this gene chip here. We can actually look at the regulation of all genes in the endothelium under different conditions, and then we can look to see what are the most important events that might be triggered, so that we can study those in healthy or diseased individuals to see whether or not those abnormalities can be corrected by our interventions. The area we were working in when we started our wine research was endothelin. Now, endothelin, this 21 amino acid peptide, is clearly important in disease pathology. It's actually homologous to a snake venom peptide from the Israeli burrowing asp. And endothelin is important, we know, in terms of vessel structure. In all the studies looking at the toxicology of endothelium antagonists, there was arteriopathies in high group treatments. So the vessel couldn't maintain its normal structure when high levels of endothelium antagonists were given. But what we know from a disease perspective is when you have a high expression of endothelin, you drive atheroma, you drive remodeling, you drive fibrosis, and actually it's probably one of the key triggers for increased vascular stiffness with age. And so that's why it's so interesting in terms of how you might intervene to lower endothelin production in people with high blood pressure or people with atheroma. There are endothelium antagonists available. They're used for pulmonary hypertension. You're probably aware of that. But they have a number of side effects. It's very common for endothelium antagonists to give you headaches because they dilate the cerebral blood vessels, and they also tend to give people stuffy noses, suggesting that endothelin plays a role in regulating nasal secretions. And quite often people are sensitive to them in a way that they get liver enzyme elevations, which means they have to be withdrawn. So understanding other ways of regulating endothelium was a goal of my lab. This is just to illustrate in terms of coronary disease in patients. If you infuse an endothelium antagonist into a normal artery, you get a small vasodilatation. If you infuse it into a diseased artery, then you get a substantial vasodilatation. So it's showing that actually endothelium tone contributes to the vascular tone in patients with coronary disease. So, and that increases the risk of actually thrombosis because the physical forces of blood going through a vasoconstricted artery are much more likely to trigger thrombosis than if the artery is dilated. Our initial study just looked simply at red wine versus red grape juice, white wine and rosé wine. Now these were all alcohol-free extracts, and we wanted to understand whether there was something in red wine that could change endothelial function. And we managed to get this published in the Christmas issue of Nature, and that was important for people's interest in our research at the time. But what we found is that red wine was very much more potent than red grape juice, suggesting that there was something in the winemaking process that led to higher levels of the active components. And we could estimate the relative degree of inhibition with these different agents using this bioassay system, and so that we could have a relative potency, which we call the effective dilution. And if you plot the effective dilution here, so the higher the number, the more potent the agent or the wine, you could see that actually there's a very good correlation with polyphenol levels in wine. But what was clear was there was a lot of wines that had high polyphenol levels or relatively high polyphenol levels with relatively little activity, suggesting that actually there was a specific polyphenol that was relevant to this activity. In other studies, this is a Japanese study, they looked at the effects of different beverages on forearm blood flow using flow-mediated dilatation. And what they found that compared to water or alcohol or wine, actually the dealcoholized wine had the most beneficial effect on endothelial function. In another study, and this is a Japanese study again, they looked at treating patients with coronary disease versus some control subjects. They treated the patients with red wine polyphenol extracts for 15 days, and they looked at coronary flow velocity reserve in those individuals, and that they could see that in the patients with coronary artery disease, they had a significantly lower level of coronary flow velocity reserve than healthy subjects, and actually the treatment with red wine polyphenols restored a better function. And this is almost certainly an effect on endothelial function as well. So there was evidence pointing towards polyphenols in wine actually changing vascular function, irrespective of what alcohol might do to the circulation. Now, a lot has been said about resveratrol, and people have argued that it explains the health benefits of wine, and I think that's probably why you had a lot of discussion about the issues about polyphenols in your last conference in Napa. Now, I'm not going to say much about resveratrol, apart from to say, is this just an urban myth, or is it a scientific reality that resveratrol can explain the actions of wine? And I think you've got to take into account that actually wine levels of resveratrol are typically 5 milligrams per litre or less in Pinot Noir. So it can be higher occasionally, because resveratrol is called a phytoalexin. It's synthesized in response to injury. So thin-skinned grapes are more prone to it than thicker-skinned grapes. The Cabernets often have, or generally have, less than 1 milligram per litre. And in fact, some Cabernets have less than 0.1 milligram per litre. So in wines that you might find in Washington State, I would guess that the levels of resveratrol in this ideal environment for grape growing are probably very, very low. So it seems most unlikely that these levels of resveratrol are going to be useful or explain the effects of red wine consumption. And I think there's been a lot of fuss about resveratrol's extending life expectancy or lifespan in mice, and it was published in Nature. The study was done in mice treated with a high-fat diet. Actually, they published the full study in a different journal, and they showed that resveratrol had no beneficial effects in terms of extending lifespan in this mice study if you looked at mice treated with a normal healthy diet. So despite this, people have gone on saying that resveratrol explains the health benefits of wine. They were using in this study up to 200 milligrams per kilogram per day in the mice in a healthy diet. And you can imagine what quantity of wine the mice were having to drink to consume that amount of wine. It's just not credible. So you can see I'm tending very much towards the urban myth. And when we translate this into human wine drinking, this is what I expect you to drink today if you are a fan of resveratrol, because it's the only way you're going to get the resveratrol benefit. So anyway, that's my opinion. I'm happy to discuss it, but I'm not convinced that resveratrol can explain the health benefits of wine. However, I accept it does have some interesting actions, and we might get some new pharmaceuticals out of studying how resveratrol interacts with gene expression, but it cannot explain the effects of red wine consumption. So what did we do? Well, we took all the polyphenols we could find available to try and account for the biological activity of red wine on our cultured endothelial cells. We used commercially available products, and so we looked at agents like quercetin, delphinidin, the anthocyanins, flavanthiols, which are present in green tea and in dark chocolate, and of course we use resveratrol. And in the concentrations that you can find in wine, none of these agents had any effect on endothelium synthesis by endothelial cells. So we set about purifying from wine biologically active polyphenols to see which could explain the actions we were observing. And you can see this is a Cabernet Sauvignon extract, French Cabernet Sauvignon, and we isolated a number of polyphenols from this extract so that we could characterize their biological activity and identify what they were. And what we found was that actually all short oligomers of epicatechin and catechin, they're what are called oligomeric procyonidins. Now, these are present in large quantities in young wines. They tend to polymerize with time, but the stability is different between different grapes. That's not really something I fully understand yet. But for instance, if you have a young Cabernet Franc in particular. Cabernet Franc can be very tannic when it's young. As it ages, it becomes smoother, but you will see it throws a deposit in the bottom of the bottle. That's your procyanidins. So sometimes wines just don't have the stability to keep these in solution. But others do very well. Now, where the procyanidins coming from? They're mainly from the seed. They come from the seed coat. You don't have to crush the seeds, but you have to soak them in alcohol to extract the material. And so that doesn't start to happen until you get to an alcohol concentration about 6%. So if you do an Australian style wine with a 4-day fermentation, you get all the colour out of the skin. So you have this nice red wine, but it's actually got very little in the way of procyanidins because the alcohol concentration hasn't reached a sufficient level to extract the procyanidins from the seed. And then these mass-produced wines, and the same happens in California as well, get separated and the fermentation gets finished off separately, so you can end up with a wine that's virtually procyanidin-free. And I think this is one of the confusing factors when you look at studies of wine consumption. People say they drink red wine when they're being asked, but actually they're drinking white wines masquerading as red wines because all they have is the colour from the skins. They're not real red wines. And so this is something that is never dialed into the equation when you investigate what somebody's drinking habits are. So obviously various winemaking processes, etc., which I'll come back to, can affect the level of these agents and grape varieties. So this for us was quite a breakthrough. And what we found was when we then looked at the level of procyanidins in wine versus the ability to suppress endothelium, there was a very clear correlation, and it was going through the origin. So we could explain the activities of red wine through the level of procyanidins. We could also show that procyanidin-rich grapeseed extracts could cause an endothelium-dependent vasodilatation of isolated blood vessels. And then we could also look at again at the relationship between procyanidin content of wine and total polyphenol levels. And you can see that typically a wine with less than about 1.5 grams per litre of total polyphenols is going to have negligible procyanidins, because that's just the soluble polyphenols that are in the flesh and come from the skin. And these are the short fermentation wines, and also the wines that are very oaked, because oaked wines give the impression of being tannic, but it's the oak tannins, and they're not biologically active in terms of endothelial function. And so you get very much this realization that not all wines actually mirror the sort of characteristics I think are ideal for a wine if you're drinking wine to get some health benefit. Some of them have astronomical levels of procyanidins, what levels that I cannot believe, but those are the sort of traditional style wines that people are making with long extraction and not using the long hang times that have become more popular in a lot of winemaking areas, because the hang time, the riper the grapes, the lower the tannins. Winemakers have known that for years, but they've pushed it so much to the level that you've got high sugar, low tannin wines that actually these are just not good wines in terms of the health benefits. And I think from what I get from consumer interaction, people don't like the level of alcohol in wines at the moment, and there should be a push back the other way, and that would also be beneficial if they're fully extracted, because they will be higher in procyanidins. So I'm going to change direction slightly here. I mean, for cardiologists, they probably recognize this as an important statement of how they interpret the data from their electron beam CTs when patients have calcium scans, where they can tell you're a 70-year-old man with 40-year-old arteries, or perhaps you're a 40-year-old man with 70-year-old arteries. I mean, these are very important phenomenon that have been recognized for generations. And so I took the view that perhaps people had the consumption of high levels of procyanidins, maybe they would change the aging process of their blood vessels. And we know that as people age, their endothelial function decreases. That's been reported by others, so it's a factor in the aging process of the vasculature. And what was interesting to me was I didn't know anything about procyanidins when I started research on wine, and then I discovered actually there is a pharmaceutical-like product out there which does seem to have some benefit. That's hawthorn extract, which is used to treat heart failure, and this is an agent. This is an agent that's really a procyanidin-based remedy, although the quantities, vary very much from product to product, but there are some standardized formulations. So perhaps, people with a high procyanidin intake would be less prone to heart failure as they age. And so the question for me was, does wine consumption influence longevity in some parts of the world? Because that would tell us also what the wines they were drinking, whether they were different from elsewhere, and whether it stood up that they were drinking wines that had a characteristics which was more likely to be beneficial than other types of wine. But I probably didn't need to do this research, because the French, on a road map in 1933, had on the cover of the road map, average life expectancy is 59 for a water drinker and 65 for a wine drinker. And 87% of centenarians are wine drinkers. And this is on a road map, so encouraging people to drink and drive, perhaps. So, in terms of the investigations I did, I mean, we hear a lot about the French paradox, but it's not a countrywide phenomenon by any means. If you look at, and the data I used for our studies was heart disease data in 1990, and this is premature death from heart disease, so under 65, versus relative longevity in 1999 based on the French census data. So you can see that in areas, and this is just each region plotted, in regions which have a high level of heart disease in younger people, then the region tends to have lower numbers of people aged 75. And that suggests that habits in those areas, lifestyles in those areas, actually influence their heart disease risk and therefore their longevity. And what was immediately interesting was it was the white wine and beer drinking parts of northern France that had the highest heart disease and lowest longevity. And it's the south and southwest areas which have the lowest heart disease and highest longevity. Serge Renaud already recognized this in his book called Le Régime Santé, where this map in his book shows the relative mortality age 45 to 54 years of age, and this is based on the 1973 to 75 data. And he saw that in this area in particular, there was a lower level of early death from heart disease in his book. And I was unaware of his book when I was doing this research, so it wasn't that I was actually following him, but I've come to the same conclusions based on our research. More recently, this was published showing that between 1998 and 2000, there's clearly some regional differences. This is Paris, so if you live in Paris now, your risk of premature death is reduced, but that's probably because you've got good medical services on hand rather than any other factors. Where if you live in the country districts that are down here in southwest France, then clearly you need to have greater reliance on your lifestyle and habits to protect you from heart disease, because there's not necessarily a cardiologist sitting around the corner waiting to open up your coronary arteries when you drop down in the street. And so you can still see that living in the north away from Paris is a bad option. So I was using earlier data than this because I think that as time has passed in recent years, wine has changed a lot. So I really wanted to reflect on what happened prior to really 2000 in terms of lifestyle habits, what was affecting longevity in different parts of France if it was wine. And you can see, the black areas are where you've got a reduced life expectancy. or not reduced life expectancy, but there's a lower number of 75-year-old men. And you have this interesting area in southwest France that clearly there's more 75-year-old men, and you might think, well, that could be because they retire there, or that, relatively speaking, young people migrate elsewhere. So we corrected this information based on the number of 75-year-old women that were living in the same area, because they would tend to live longer anyway. If we could still see something unusual, correcting it for the number of 75-year-old women, then that would suggest a hotspot of longevity and reduced heart disease. And what we did this now on a department basis rather than on a region basis, and we found one department was particularly different from the rest. The second one down, Ariège, is a mountainous district on the edge of the Pyrenees, and lots of studies have shown that if you live at higher altitude, that benefits your well-being. That's probably because people are fitter without really realizing, rather than any specific dietary habits. And certainly Ariège is not a wine-producing area. So Gers was very interesting. I didn't know where Gers was. I hadn't tasted their wines, so it was clearly something I had to investigate. And so I went with my wife to Gers to find out about their wines, and found that around Gers there's basically three main appellations. There's also the Côte de Gascon wines that cover all of this area. But what was actually fascinating about these wines, that they were using a different grape to elsewhere in France. That they were primarily basing their wines on the Tannat grape, which was a grape I was not familiar with when I started this research. So it was actually, quite interesting to find that the area with the highest longevity had a grape that nobody else was using to any extent, and often the wines were 100% Tannat. And so this suggested actually the grape could be very interesting, or a component of that. And when we tested these wines in the lab, you can see that actually they are much more potent than your average wine. These were some US wines that I had managed to get to the UK before we were stopped taking wines on aeroplanes in your hand luggage. And these are various wines that are available in the UK in wine merchants. So basically, I found that actually there was a consistency. They had a different grape. This grape was richer in procyanidins. It had more biological activity, suggesting that what we had discovered was really relevant to understanding how wine could be beneficial for health. And there are lots of factors that affect this, though, because obviously the grape variety is critical. I've mentioned grape ripeness, but terroir is critical as well. Along the way, I observed that actually clay soil, as you can find in Washington State, higher altitude, and the yield of grapes all impact on the polyphenol synthesis in grapes. And you can make a high procyanidin wine with many grape varieties, provided the winemaker is looking to have a well-extracted wine, and he or she is looking to have something that isn't made from grapes that are hung until the grapes are shriveled like raisins, and so that they're so concentrated you can't really make a wine from them. If you have a grape that's just right and you have a good extraction, you can create high procyanidin wines. And I just want to show some comparison of some data I've collected. The numbers reflect the number of wines that I've analysed. I've compared Cabernet Sauvignon here, the total polyphenols. This is the range of values I found. This is the medians and the quartiles. And you can see that actually Cabernet Sauvignon can produce a very polyphenol-rich, procyanidin-rich wine. It's very much a question of the winemaker. It can also be used to make some of the lowest polyphenol wines, depending on how the winemaker operates and the environment. And I've compared it to some Southwest France Tannat wines and some Sagrantinos from Italy. The Sagrantino is probably the grape the most similar to Tannat in terms of the type of wine that it makes. It's very coloured, and very tannic, and it's actually fantastically, these wines tend to have a bit of acidity and lots of structure, and from a wine drinking point of view, I think are perhaps optimal, and I'm just pleased that I found them to be so beneficial. You might think that's a conflict of interest, that I found the wines I like by my research. But actually, no, the research was never set out to find that, but I'm actually, what I tend to drink now is obviously influenced by what I found. But you know, the winemaker is critical in what you end up with in the bottle. Just for comparison, I've got some Washington State Cabernets. They tend to be higher on average than Californian Cabernets. The range here is a reflection on, actually, there's lots of things happening in Napa and the Napa Valley area, and some of the winemakers that are on Mount Vida are actually making some very procyanidin-rich tannic wine. People like Hess Collection are making some fantastically structured wine, and really, in my view, they're the only wines that compare to the sort of quality you get in the Washington State wine. What's interesting, the Washington State wines tend to be a lot more consistent, and that's probably because the environment means that you can manage your grape ripening in a very consistent way, and I think that's a factor. But typically you get a good procyanidin content in a Washington State Cabernet. For my book, I developed a heart rating scheme that looked at picking out wines that I thought people should be drinking if they wanted to actually cut their alcohol consumption and drink more procyanidin-rich wines. And the way I set the scale was actually, these are the sort of 1 to 2 heart wines, which are shown here. These are the ones I think people should steer clear of. 3 hearts and above are the ones that are more rich in procyanidins, and the 4 and 5 heart represent the top 10%. And this scale was based on wines excluding the Maderon wines and the Sagrantino wines. It was just your average wines that I had evaluated over the period that I was writing this book. And so the 4 and 5 heart wines reflected the top 10% of wines from a procyanidin perspective. And it's clear, consumers want to know about what's in the wine. They don't want to just see the alcohol concentration. They want to, I know some want to see resveratrol levels, but others want to see the polyphenol levels, the procyanidin levels, and I think it would probably help consumer choice in terms of trying to help people balance the amount they drink if they knew that they were drinking a bottle of wine that 1 glass was better than 3 from another, on the basis that they would probably drink less and cut the risk of the adverse consequences of alcohol. So as I mentioned, grape ripeness is critical, and I think the current trend has to stop. There has to be a drive amongst winemakers to get back to some of these lower alcohol wines, because actually most of the wine and health studies that are typically the ones that Serge Renaud is an author of are based on people drinking wines of 11 to 12% alcohol, not 15 to 16% alcohol. And what's really bad in the US is you don't have to report accurately the alcohol levels in the wine, providing you have got 2%, providing you're within 2% of the actual value, that's okay. So what many winemakers do in the US is they put 14.5%, because that implies better quality, but it may actually be 16.5%, and people are actually duped into thinking it's only 14.5%, and this is a dangerous level of alcohol. It's very easy to exceed safe levels of alcohol consumption. And also the lower procyanidins, as I mentioned, is also an issue, but we used to think that half a bottle a day was okay, it was safe, it was a healthy amount to recommend, but we can't if these levels of wine, alcohol in wine, are so high. You would have to say that only 2 small glasses or 1 large glass was in the safe levels of alcohol consumption. So I think, I know winemakers want to get their Robert Parker scores, but I think they have to reflect on whether that's what people want to drink every day of the week. I mean, I'm happy to drink occasionally a fantastic wine, but I want to be able to drink something that I don't wake up with a hangover because I've consumed more than I anticipated, that I can go to work knowing that I've drunk an enjoyable glass of wine with my evening meal and not going to suffer the consequences. And I'm sure that 90% of people in this room probably feel the same way on work days, that they need to actually moderate or not drink wines of such high level of alcohol. So, in summary about wine, because I'm going to spend the last 15 minutes talking about some mechanisms of action that we're working on. That will help with your CPD credits. So I think that's an important element of my talk. I think that wine drinking does confer health benefits if combined with a healthy diet, and that's very clear. And some wines may be providing greater protection from heart disease, but I'm very concerned about current trends in winemaking styles and the risk of overconsumption of alcohol. I quickly want to mention cocoa. Now, cocoa is the other source of procyanidins that people are most likely to encounter. So are apples, but only apples that are not overripe, because when they're overripe, the procyanidins level goes down. Now, this woman here, Louise Kalman, she is Guinness Book of Records verified the longest living woman ever. She lived to 122 years and 164 days. This is her age 120 in 1995. And I wonder if chocolate influences longevity in the same way, because she claimed to eat up to 1 kilogram of chocolate per week until her doctor advised her at 120 that it wasn't healthy to be eating this amount of chocolate. So I think the cocoa area, because it's the same polyphenols that grapeseeds have, is also interesting to follow. The Kunar Indians of the San Blas Islands of Panama have a very low level of heart disease, and they don't show any age-related hypertension. And this is thought to be due to the fact that they're drinking 5 cups of a very crude cocoa a day, up to 5 cups, which is incredibly rich in procyanidins and other flavonols. And if you look at the data, this is island blood pressure, and this is work by Norman Hollenberg from Harvard. Island blood pressure compared to Kunar Indians migrating away to other areas of Panama, and you can see they show the typical age-related changes in blood pressure. If you want to compare dark chocolate with red wine, and this is a pretty average dark chocolate for the UK, but also similar to what you might find in the US. If you compare the relative potency in terms of our biological responses, and people often say dark chocolate is a richer source of antioxidants than red wine. Well, possibly, and it may have some activity that's greater, but to get the same equivalent doses, you want to have 60 grams of chocolate to 1 glass of red wine. And, you know, frankly, I can manage 2 glasses of red wine in an evening, sometimes 3, but I couldn't eat 180 grams of dark chocolate to get the equivalent amount. So suggestions that dark chocolate's a better choice than red wine, if this is what you're trying to do, it's completely flawed, just from a calorie point of view, from a quantity of consumption point of view. And so I think you should bear that in mind if you're thinking of substituting from wine to chocolate. The interesting thing about what's been done with cocoa at the moment, and we've got dark chocolate clinical trials going on because it's much easier to get ethics permission to do those and to do red wine trials, is that it's most noticeable that you get an improvement in flow-mediated dilatation with cocoa treatment and flavanol treatment in more elderly groups. This is over 50 years of age. And this fits with the idea that the endothelium is this key risk factor. If we can improve these flavanol consumption from different sources, we can actually have a protective effect, and that will contribute to better cardiovascular health. So the same components are responsible for chocolate and chocolate products. So how do these agents work? Well, I can tell you straight off, it's not an antioxidant effect. It really isn't credible. And it's likely, based on research we're doing at the moment, that it's a structure-activity dependent effect, that not all of these molecules are active. Some are very potent, and that implies some sort of pharmacology, that there's a receptor or protein that these interact with to stimulate the changes in endothelial function that we're observing. If you look at it from an antioxidant perspective, you only ever get polyphenol concentrations in blood of around about 200 nanomolar max. And this is way off the antioxidant capacity of blood from different sources. So antioxidants actions are unlikely to explain any beneficial effect of flavonoid consumption or other polyphenols. One of the things we discovered early on was if you looked at endothelial cells in culture, you can see that when you treated endothelial cells in culture, you can get a very rapid change in cytoskeleton and phosphorylation of proteins at points of cell-cell contact, implying that actually there was a beneficial effect triggered by these agents, or because we reckon, or an effect that's triggered that's very rapid, that we link to the beneficial activities. And what we're interested to observe that if you applied shear stress, and this isn't our work, but if you applied shear stress to endothelial cells, you got a very similar change. The cytoskeleton change, and there's phosphorylation of proteins in the endothelium at points of cell contact. And from our perspective, we knew that laminar shear stress is probably the most protective force in the vasculature. And where the points we get atheroma are points where there's no laminar shear stress, there's turbulent flow that actually means that the endothelium is not healthy. And so if you had an agent in your diet that could make the endothelium behave like it was a healthy bit of endothelium in a straight part of a vessel, then actually that would be very protective. And so we came up with the concept that these agents were stimulating what we called the pseudo-laminar shear stress response, a sort of pharmaceutical response, pharmacological response that was protective in the endothelium, which suppressed endothelium production and increased nitric oxide production. So you actually had converted a atheroma-prone area of blood vessel to a vasodilated atheroma-resistant piece of blood vessel. And we drew a list of differences, or similarities, between the effect of procyonidins and the effect of shear stress. And we could show that endothelium-dependent vasodilatation, induction of eNOS expression, suppression of endothelium synthesis, the signaling changes, we could see all of these were occurring with our procyonidins in the same way as laminar shear stress caused them. And laminar shear stress was also known to be anti-inflammatory and antithrombotic and had other protective changes. From a perspective of nitric oxide, nitric oxide is not just important for vasodilatation, it reduces platelet stickiness and adhesion. So any agent that can stimulate nitric oxide production would have value in protection from heart disease. Nitric oxide is also, it operates as a dimer. It's most active when it's phosphorylated, and it converts arginine to citrulline and nitric oxide, but it's completely dependent on the cofactor tetrahydrobiopterin. And when we look in cell culture, we can see that the eNOS protein increases with the treatment with procyonidins, and it also migrates to points of cell-cell contact, which actually is where it's most active, bound to the cell membrane. And we could also see that it got very rapidly phosphorylated. Within 5 minutes of treatment, it got phosphorylated and migrated to the cell membrane. So an agent that can do this in your blood vessel wall is going to have a very useful protective activity in increasing nitric oxide production. What we also recognized was it actually increased the expression of the gene that makes the rate-limiting enzyme in the synthesis of tetrahydrobiopterin, which is GPC cyclohydrolase. And so we could actually see a potential here to treat endothelial dysfunction by promoting BH4 formation. Now that's a bit of the holy grail of treating endothelial dysfunction, because it's recognized without BH4, this enzyme, nitric oxide, will actually produce reactive oxygen species. So we're not only promoting nitric oxide production, we're protecting from the likelihood of these adverse effects of superoxide production. What's also interesting from our research is that there's a transcription factor called cripple-like factor 2. Now, KLF2 for short, this is the endothelial cell master switch. When its expression is increased, it causes all the changes that flow-mediated dilatation causes. If you want to read about it, this is probably the paper to look at. It looked at the effects of flow versus overexpression of KLF2 in endothelial cells and found that it could account for all the effects of the flow-mediated response. And there is a number of reviews that suggest that actually an agent that could increase KLF2 could actually be very useful in protecting from heart disease because it's anti-inflammatory, it promotes vasodilatation through increased eNOS and suppression of endothelium, and it is also antithrombotic by suppressing things like tissue factor and PI1 and also increasing thrombomodulin and TPA. So it has a profile of activity that's very interesting. So it was fascinating when we started looking at red wine procyanidins versus cranberry, which is another source of procyanidins, and showed that actually these could stimulate KLF2 synthesis in our endothelial cells, and that mirrored the sort of changes we were seeing with endothelium suppression and with eNOS production. So we have an agent that is dietary that can trigger this important change in KLF2 regulation. And so we did microarray studies to look at this further. Fascinating amount of data it's generated. I hope to get this published soon. We saw about 200 genes of mRNAs were upregulated, about 300 genes they were suppressed. All sorts of interesting mechanisms going on. Very close correlation between cranberry and red wine, so on those nights you don't want to drink high alcohol wine, then the cranberry juice might be an alternative. And this is sort of mirrored with some of the studies that KLF2 show. It's been shown to suppress these cytokines. It's been shown to suppress this BMP4, which stimulates vessel calcification. It's been shown to suppress GRO alpha, which is a chemokine that's important in attracting monocytes into atheroma. And so we're seeing all the effects, not only in KLF2 induction, but we're seeing the effects that KLF2 is known to cause with our extracts. And finally, what I want to mention quickly is the very interesting antithrombotic and thrombolytic phenotype that procyanidins induce in the endothelium. Now, you're all familiar with this clotting cascade. It's probably something you learned as an undergraduate and have ignored ever since. I certainly fitted that category. But it was interesting to find genes that related to this clotting cascade when we were doing our research. Now, key triggers for coagulation are the phospholipid scramblases on the endothelium. They put phosphatidylserine on the cell surface, and that's a cofactor for factor 8 and for factor 10 activation. So if you suppress the levels of these proteins, there'll be less phosphatidylserine, the endothelium will be less sticky, and it also reduces thrombospondin 1, which stimulates platelet aggregation. So all effects that would make the non-stick nature of the endothelium more pronounced. But it doesn't stop there. Antithrombin 3 binds heparan sulfate to inhibit these various clotting cascade factors. And we found that red wine procyanidins, actually, one of their most pronounced effects was upregulation of the rate-limiting enzyme in heparan sulfate synthesis. So you have this potential to the endothelium to be more anticoagulatory than it is without this treatment. And it goes on. Thrombomodulin, which binds thrombin, converts protein C into activated protein C, and then inactivates the prothrombinase complex. We found that thrombomodulin was upregulated by procyanidins. This is also a KLF2 regulated gene. And finally, from a thrombolysis perspective, plasmin will break down fibrin and so reduce clot formation. And it's an important mechanism, because if you have a increased plasmin production locally in the vessel wall, then if any microthrombi start to form, then the endothelium can start to digest them before they start to get bigger and occlude the vessel. And we found that actually plasminogen, U-type plasminogen activator and T-type plasminogen activator, as well as the receptor for U-type plasminogen activator, were all upregulated by procyanidins. And so you can imagine that a healthy consumption of these agents from whatever sources can actually change your endothelial function in a very protective way. Other things we found, we had a lot of pro-inflammatory and pro-atherosclerotic genes suppressed, particularly genes that stimulate remodeling and so are more likely to be related to reducing blood pressure than to actually anti-atheroma effects. And we've got a spectrum of metabolic gene effects. Some of them are really fascinating. Probably the most important from our perspective is the suppression of HMG-CoA reductase. So we have a statin-like effect on the endothelium through procyanidins, which I think is absolutely fascinating. So I'm keen to get this published. So what we can conclude is that extensive modification of endothelial function is likely to contribute to the vascular actions of procyanidin-rich wines, and high dietary consumption of these wines is more likely to improve well-being and decrease risk of heart disease than low procyanidin wines, but obviously there are other sources of these agents. What's the future for us? Well, we're doing double-blind placebo-controlled trials. What we're also working on is we're working on biomarkers of vascular dysfunction so that we can actually assess in a different way than just measuring cholesterol who's the most at risk and whether these interventions are protective. We need to work a bit more on the bioavailability and eventually get to the point we can do some large-scale outcome studies. So that's pretty much all I want to say about my research. I just want to bring one final item to you where I'm probably looking for the support of the Renault Society, because I just learnt today that the Office of Alcohol Control in Lithuania is going to take legal action against my publishers there for promoting consumption of alcohol. And in fact, my book, if you've read the book, will know that it's actually completely the opposite. I'm trying to say reduce the alcohol consumption and pick better sorts of wine so that you actually cut down alcohol and don't drink beer or spirits. So this is a surprising legal action that I discovered in an email this morning. If anybody wants to actually, who've read the book and want to come out and say that in a professional capacity they think that I'm promoting moderation rather than what they're claiming here, I'd be very much like to speak to you. So thank you very much.